Okay, I'll let you pause and read the question real quick here. Basically, we have all of these jars of this moonshine here, and we need to get a sense of what the overall average percent alcohol is. So we can't test them all. We test 28. Notice this randomly selected. That'll help us meet one of the assumptions. We get our average for our sample. And we're going to make this assumption about the population standard deviation of these moonshine jars. There's certainly going to be a lot of variation, certainly a lot more than we would find in, say, alcohol at a store, because it's homemade, because there's that uncertainty. And this is an unrealistic assumption here, but we're making that for the chapter 14 situation. And we're going to try to get a sense on what that average alcohol is for the entire place that they've rated here. So there's three conditions we're checking really quickly. Simple random sample. That allows us to generalize the results of the sample to the population. We have that. We know that these percentage alcohol of each jar, if we take all the different percent alcohols of each jars and plot them, it would be a normal distribution. And we have standard deviation of the population given to us. So here are some other values that it's worth mentioning. N is sample size. We have 28 jars in our sample. Given the population standard deviation, this Z star, where's that coming from? So that's the 95% confidence interval cutoff, basically. How many standard deviations are we going to go above and below our sample mean? And in this case, 95% confidence interval would be the 1.96. We also looked at that in class. X bar is our sample mean, 36%. So 36% is our best guess at the mean for that entire storehouse, right? It's good to mention that right off the bat. That's the closest single estimate we're going to get, but we know that that's not exactly right. And so we're trying to create this plus or minus idea, like, yeah, maybe it's a little lower than that for the entire thing, and maybe it's a little higher than that. So how much above and below are we going to go? Well, here's where that 1.96 comes in. We're going 1.96 standard deviations. And when I say standard deviations, I mean in our sampling distribution of the mean. So these types of standard deviations. So we're taking that 10, adjusting it by square root of sample size there. And that gives us, so 10 was the standard deviation of the original jars, one at a time, taken one at a time. This right here, this fraction 10 divided by square root of 28 is the standard deviation of sample means when our samples are size 28. And so that's going to be much smaller than our original standard deviation. In fact, it's going to be 1.89, which is quite a bit smaller than the 10 we were given. We multiply this to figure out how much we're going above and below. So we're going above and below 3.7, subtract it from 36 to get 32.3, add it to get 39.7. So again, we were dealing with a 95% confidence interval. That came into this 1.96. If that had been a different level of confidence, this number here would have been different. We're 95% sure that as long as we met our assumptions, that the true value of the average percent alcohol for all those jars in that storage facility is somewhere between these two numbers. This is kind of our lower end estimate. This is kind of our upper end estimate. It's possible that the true average is somewhere outside of that. There's about a 5% chance of that. But we're 95% sure that it's somewhere between these two numbers. And just to point out this note here, all of these percents you could have used, as long as you were consistently, you got to choose one, either do percents throughout the entire thing or proportions throughout the entire thing. But as long as you did that, you should have ended up with the same two numbers there, 32.3 or 0.323 for the lower, 39.7 or 0.397 for the upper.